Welcome to AI TechNav, your trusted guide to navigating the exciting world of artificial intelligence and technology. Today, we'll explore the fundamentals of machine learning with simple yet impactful examples. Whether you're new to the field or looking for a refresher, this guide is for you. What is machine learning? Machine learning is about creating systems that can learn from data to make decisions or predictions. It powers many of the tools we use daily, from voice assistants to recommendation engines. Let's dive into two fun examples that illustrate the key concepts: classification and regression. Example 1. Classification with a decision tree. Imagine you're trying to predict whether someone will enjoy AI TechNav. You start by asking a series of questions. 1. Do you enjoy solving puzzles? 2. Are you interested in learning about artificial intelligence? 3. Do you like collaborating with others? Based on their answers, you can use a decision tree to classify people into two groups: those who are likely to enjoy AI TechNav and those who might not. For example, 1. If someone enjoys puzzles and is interested in AI, the tree predicts they'll love AI TechNav. 2. If they dislike both, the prediction might go the other way. This is an example of classification, where machine learning helps group data into predefined categories. Example 2. Regression with coffee consumption. Let's explore a new example of regression. Imagine you're studying the relationship between how much coffee someone drinks and their productivity at work. 1. Some people drink no coffee and have moderate productivity. 2. Others drink a lot of coffee and are highly productive. By plotting this data, you notice a trend: more coffee correlates with higher productivity, to a point. Visualize a graph. 1. The x-axis represents coffee consumption, in cups per day. 2. The y-axis represents productivity, measured in tasks completed. Drawing a straight line through the data points gives you a model to predict productivity based on coffee consumption. For example, 1. If someone drinks 3 cups of coffee, you can estimate how productive they'll be during the day. This is regression in action, using machine learning to predict continuous values. Understanding the bias-variance trade-off. Machine learning is not just about fitting data, it's about making reliable predictions for new, unseen data. This is where the bias-variance trade-off comes into play. 1. Bias. When a model is too simple, like a straight line, it might miss important patterns in the data, underfitting. 2. Variance. When a model is too complex, like a wiggly curve, it fits the training data perfectly but struggles with new data, overfitting. The goal is to find a balance where the model is complex enough to capture the data's patterns but simple enough to generalize well to new data. Why simplicity often wins. You might wonder why we're focusing on simple methods like decision trees and regression lines instead of advanced techniques like neural networks. The answer lies in generalization. A simple model that performs well on new data is often better than a complex model that overfits the training data. No matter how advanced a method sounds, its effectiveness is judged by how well it performs on testing data the model hasn't seen before. Evaluating machine learning models. To evaluate a machine learning model, follow these steps. 1. Split your data, divide it into training data, to create the model, and testing data, to evaluate the model. 2. Make predictions, use the model to predict outcomes for the testing data. 3. Measure accuracy, compare predictions to the actual outcomes. For instance, if your decision tree predicts someone loves AI TechNav but they don't, that's an error. Testing multiple models helps you find the one that works best for your use case. Key takeaways. Here are the main points to remember about machine learning. 1. Predictions and classifications. Machine learning models help make predictions and classify data into meaningful groups. 2. Testing data is critical. The real test of a model's success is its performance on data it hasn't seen before. 3. Simplicity versus complexity. The best model balances accuracy and generalization, often favoring simplicity over complexity. Your next steps with AI TechNav machine learning is a fascinating field with endless possibilities. If you're eager to learn more, AI TechNav offers resources, tutorials, and mentorship to help you explore this dynamic field. Whether you're a beginner or an experienced professional, we're here to guide you on your AI journey. Subscribe for more guides, or join our community to connect with peers and mentors. Until next time, keep exploring with AI TechNav.